In this video, we're going to look at using integration to find areas. So, in this in this graph here, I have the function y equals x squared minus 2x plus 3. And in order for me to find the area underneath this curve, between the curve and the x-axis, so what I'm talking about is all this area in yellow. So anything underneath the curve, between the curve and the x-axis, so all of that. If I want to find that, here's what I do. I first of all take the function and write it out. Squared 2x plus 3 dx. Okay, now let's just look at this graph. I want to find all this area in yellow, so it'll be starting where x is 0 and ending where x is 4. Okay, because that's where I've ended my curve at 4. So I would have a 0 here and a 4 here. Now here's what I do. I'll integrate this function. So if I integrate this function, I will get x cubed over 3 minus 2x squared over 2 plus 3x. Now we don't have to put in the c. And again we have our 4 here, and we have our 0 here. What I do now is I put 4 in for x and get an answer, so I'll do that. So that would be 64 over 3 minus 32 over 2, which is 16 plus 12. So that's that bit done when I put 4 in. Now I'm going to take away what answer I get when I take the 0 and put it in for the x's. Okay, so put 0 in for the x's. If I put 0 in for the x's, I'm going to get 0 cubed over 3, which is 0 minus 0 plus 0. So anytime we put 0 in for the x's, we're just going to get 0. Take them away from each other. So it will be, first of all, 0, and so that's 17 and a third. So 17 and a third, and it's area, so it's units squared. Okay, so the yellow part, 17 the third unit squared. Okay, let's look at it again. This time I want to get the area from, we'd say, x is 2, so here, and up to x is 4. So I want to get the area of all this. Okay, I'll just put in yellow. So I want to get the area of all this, not this bit. Okay, so I do that over here. Right, same again. The way we set it up. We have our integral, x squared minus 2x plus 3 dx. However, this time, yes, we have a 4 up here because that's where our area ends. However, we're starting at 2 this time, so instead of 0, it's a 2. Next we'll integrate, and just like the last time, we will get x cubed over 3 minus 2x squared over 2 plus 3x. And we have a 4 here and a 2 here. So minus 1 for the other. And when we put the 4 in for the x, we know already we got 64 over 3 minus 16 plus 12 minus, and then we're going to have to put the 2 in for the x. So that'll be 2 cubed over 3 minus 2 squared over 2 plus 3 2. So this will give us 17⅓, this one here, and we'll take away whatever this answer is, and if we work all this out, it's 4 2/3, and that will give us 12 2/3 units squared. Okay. Likewise, if this curve continued and I wanted to get the area of, let's say, between x is 3, so between here and x was 6, so here, all this area, I'll do the exact same again, except this would be 6 and this would be 3. Okay, so that's how to get the area between a curve and the x-axis. Okay, so look, we've got the area between the curve and the x-axis. So down here, we haven't looked at the y-axis yet, but we will now. Okay, so in this question, we want to find out the area between the function, the line, and the y-axis. So we want to find out the area of this, okay, where y is 2, where y is 10. So between this section here. Okay, so how do we do that? Because we're already after knowing how to find the area of this section here between the curve or the line and the x-axis. Okay? If I wanted to find out the area of this, I would just integrate this, put in 0 then and whatever number that is, and it would give me the area. However, now I'm looking for the area between the curve or the line and the y-axis. So I have to do something to this first. What I have to do is I have to make it look like x equals something. So I have to write it in terms of x. So to write this in terms of x, just do a bit of algebra. Take 2 from both sides, or sorry, add 2, don't take 2 from both sides, so it'll be y minus 2 equals x over 2, and then multiply both sides by 2 and we get 2y minus 4. So now I can say x equals 2y minus 4. Okay, now what I do is I write out my integral from that. So I have this 2y minus 4, and instead of writing dx this time, it's dy. Okay? And I want to find out that integral between these two numbers, between 2 and 10. So the bigger number goes on top, so that's 10, and this is 2. So next up, I will integrate. So if I integrate this, I will get 2y squared over 2 minus 4y, which will give me, if I simplified, y squared minus 4y. And I want to find that out between 10 and 2. So I'll put 10 in for y first, so we'll do it over here. So 10 squared minus 4 tens, so that's the first one. And then take away the same thing when I put 2 in for y, so 2 squared minus 4, 2. This will give me 100 minus 40 is 60, minus 2 squared is 4, minus 4 minus 2 is 8, so it's minus 8, that's 60 plus 8, which is 68 units squared. Okay, so that's that area here. If I just wanted to find out, say this area, this bit here, I'll put it in yellow. So this, I'll do the exact same thing, except the 10 will change to 7, and the 2 will change to 4. Alright. The first thing I could do is I could find the area of the curve between the curve and the x-axis, between this point and this point, so between 1 and 3. So I could find the area of all of that. And then, when I've that done, I could find the area between the line and the x-axis from the same points, 1 and 3. So I could find the area of all of this. And if I took the area of all the yellow, sorry, if I took the area of all the yellow, and then take away this bit here, this red, I would be left with the area of this, which is what I wanted. Okay, so that's what I'm going to do. So I'll just tidy this up a bit. Right. So the first thing I'm going to do is I'm going to get the area from the curve to the x-axis between point 1 and 3. So basically in red here. So all the area in here. So how do I do that? I'll take this function and I'll integrate it. And when I integrate it, here it is, minus x squared plus 5x minus 4, and I want to find that between where x is 3 and 1 dx. So if I do that, if I integrate that, I will get minus x cubed over 3 plus 5x squared over 2 minus 4x. And that's between 3 and 1. Okay, so I've done that. Now what I want to find is the area between here with all this. So I want to find the area of all that. So what I do, take this function and integrate it. So this function is x minus 1. So integral 1, 3 again, x minus 1 dx. So if I integrate that, I will get x squared over 2 minus x. So I'll write that down here. X squared over 2 minus x. Now, and what did I say I had to do in order to get this area? Yes, I had to take this bit, this black bit, away from the whole lot, which I got earlier. So all of it. So I would have to take these away from each other. Right, so I'll do this bit first. And this bit will give me -9 plus 22.5 minus 12, that's when I put 3 in, minus a third plus 5/2 minus 4, that's when I put 1 in. So that's that done. Now I have to minus, so minus there, and now I'm going to do this bit. So when I put 3 in, I will get 4.5 minus 3 minus, and when I put 1 in then I'll get 1/2 minus 1. Figure out what this answer is, and this answer I have 1.5 plus 1/5/6, so that's this bit done, minus, and then this bit over here do it, which is 1.5 plus 1/2. And when I do that, then when I minus 1 from the other, I get 1.3 units squared. So basically, this here, this bit here, this black bit I'm shading in, is 1.3 units squared. Okay, and just to be conscious that I've given you the diagram here and we've worked from it. Sometimes they may just give you something like this. They may say, and I'll write it out, find the region bounded by the curve y equals minus x squared plus 5x minus 4, and the line y equals x minus 1. They might just give you this. They might give you the diagram. They might just give you that. If they do just give you that, you really need to sketch all of this from this information. Okay, so when you're dealing with areas from integrals, please do sketch it. Okay, the last one then. What I want to do is find the area between the curve and the x-axis, between where x equals 1 and x equals 4. Now let's just see that. X equals 1 is here. So the area between x is 1, start here, and will end here. I'm going to draw this curve a bit further. Now, right, let's look at the areas. So the first one, well, the area between the curve and the x-axis will be here. Okay, and then the curve meets the x-axis, so there'll be another area here. Okay, so if you need to pause that and just have a look and get your head around it. We're looking for the area between the curve and the x-axis at point 1, so it's going to start here, and 4, so it's going to finish here. This time the area is divided into two parts, part A and part B. Okay, So we're going to have to do this into two separate sections. So it's not as simple as just taking this function, integrating it, and then putting 4 in for x and then 1 in for x. The reason being is because there's two separate areas. If there's two separate areas, we're going to have to do two separate sums. So here's what I do. Okay, so I'll take the integral x squared minus 4 dx, and I'm going to integrate it. So if I integrate it, I will get x cubed over 3 minus 4x. So that's it integrated. Now I'll do this bit first, this area A. So this area A starts at x equals 1 and finishes at x equals 2. So I have to do that. Okay, so let's get the area of that first. And that would be 2 cubed over 3 minus 4 divided by 2. So that's the first bit. Minus, now I'll put 1 in for x. So 1 cubed over 3 minus 4 ones. And we get minus 1.66. Strange. How can we get a minus area? Up here, that's an area, but it's a minus. Well, the reason of that is because it's underneath the x-axis. So any areas underneath the x-axis, they would be given as a minus. However, common sense and mathematical knowledge will tell us that an area has to be positive, so we will take its positive value. So this is the area of A. Now we need to get the area of B. So we can take this integral, okay, because it's already integrated for us. And now we'll put this here, which is x equals 4. And this here again, which was x equals 2. And we work that out. So we have 4 cubed over 3 minus 4 divided by 4 minus 2 cubed over 3 minus 4 divided by 2. So when we work all this out, we get this. If I work this out and minus both of each other, I get 10.66. So that's the area of B. What do you think we do with both of them? Because we want to find the combined area of A and B, we will add them. And we will get 12.33, or if you want 12 and a third would be better. Okay, and it's units squared. That's it, guys. Hope that helped. Secret to this is practice, as with most maths. Okay, thanks.